In section 5.2.42, a university conducted a survey of 404 undergraduate students regarding satisfaction with student government. Results of the survey are shown in the table by class rank, and we're going to complete part A through D below. So you have freshman, sophomore, junior, senior, and then satisfied, neutral, and not satisfied. So here we total up the column for freshman, sophomore, junior, and senior, and then we also total up the rows, which are satisfied, neutral, and not satisfied, and we can see that the total becomes 404. Now, the first question states that if a survey participant is selected at random, what is the probability that he or she is satisfied with student government? So, to find this probability, we're going to divide the number of students in the survey who are satisfied with the student government by the total number of students who participated in the survey. So we're trying to find the probability of satisfied. Well, that means here that if we take a look at the total number, okay, that were satisfied, which is 240, since that is the amount for 240, and then we're going to divide it by the total number in the survey, which is 404. So we take 240 divided by 404, which gives us a result of 0.594. Next question states that if a survey participant is selected at random, what is the probability that he or she is a junior? So what we're going to do is we're going to take a look at the column, which is a junior. Now, it doesn't matter whether it's satisfied, neutral, or not satisfied, but the total junior is 102. So we're looking at the probability that it is a junior, and then we're going to divide it by the total number that's surveyed, which is 404, which gives us a result of 0.252. Now the next question states that if a survey participant is selected at random, what is the probability that he or she is satisfied and a junior? So we're looking at satisfied and a junior. So we're looking at, that's the row, and then that is the column, but where do they intersect? Well, they intersect at 68, because that means that 68 represents that it's a junior and they're satisfied. So what we're going to do now is we're going to take that result, which is 68, and again divided by the total number that's surveyed, which gives us 0.168. Now the last question, it says if a survey participant is selected at random, what is the probability that he or she is satisfied or a junior? So if you take a look at the last question, okay, and was important because that means intersection, meaning what do they have in common? So they have to be satisfied and a junior. But in this scenario, we have the or statement. So that means they can either be satisfied or a junior. So let's take a look at that. We know that for our formula, okay, we need to know that this represents the general rule. So the general addition rule, to find the probability, the rule states that for any two events, E and F, to find the probability of event E or F would be the following rule. So we're trying to find the probability that it's satisfied or junior. So what is the probability that they are satisfied? Well, the total number that's satisfied is 240. And then we're going to add the probability of how many are juniors. So that means that we have a total of 102. And then what we're going to do is we're going to subtract the probability that is satisfied and a junior. So that means we need to subtract that number because that is the intersection, which is 68. And then each one of those numbers is being divided by 404. And then when we combine all them using order of operations, we would get the result of 0.678.